Hello everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent, and in this video clip I would like to discuss with you how we can easily calculate chi-square values from a 2x2 contingency table. And this is something that we might come across quite frequently when we do, for example, surveys. So here is the problem. We surveyed 82 women and 18 men. And they were asked for their favorite pet. So we've got 100 people. 20 women preferred cats and only 5 men preferred dogs. And the question is there a gender bias in the pet preference? Or in other words, do women prefer cats while men prefer dogs? Or is there no difference between them? Now, first of all, we have to set up a hypothesis that we want to test. And we usually set up a null hypothesis. So our null hypothesis in this case would be that there is no difference. There's no difference between men and women when it comes to pets. So both men and women equally like cats and dogs. The alternative hypothesis is there is a difference. There is a difference between the genders, with respect to pet preference. Now we need to test which of these two hypotheses is true. And we usually do that at a critical significance level. Of 5%. This means how sure do we want to be that we make the right decision? So we want to be sure 95%, and these 5% is the remaining, if you like, remaining risk that we make the wrong decision. So how can we address this question? Well, we can set up a decision tree, and I've done that here. So we said we have 82 female and 18 male, so that's 100 people. And now we calculate the expected values that we want to have. Or if there is the expected value, if there is no gender preference, if there is no gender preference for the pets. Preference. Now our decision tree here, we've got the gender, 82 out of 100 women, and if there was no gender preference, then they would like cats as well as dogs, so there would be 50% cats and 50% dogs. So out of these 82 women, 41 would prefer a cat, 50 of 82, and 41 would prefer a dog. And with the males, we have 18 males out of 100, and if there was no gender preference, we would have 50% like cats, so 50 out of 18 is 9 men like cats, and 50% would like dogs, so 50 out of 18, again, that's 9 men like dogs. And we can set up a contingency table with this. with our expected data if there was no gender preference. So here we've got the table with the expected values if there was no gender preference. Was no gender preference. And here we have our actual data. This is the survey. So we found that in the survey, 20 women like cats, and obviously 62 women like dogs, because that gives us 82. And we found that 5 men like dogs, and because we know that we surveyed 18 men, we know that 13 men like cats. So we now want to find out whether our survey data are similar to our expected data. And with this we can do with a chi-square test. A chi-square test compares frequencies. Chi-square test, so we have frequencies. How often do men like dogs and cats? How often do and how closely is this to our expected value? Now, we could calculate this by hand, but there is an easier way. And what we can do is we can make use of an online resource. So let me quickly close this, go to the online resource. And here, this is the online resource at graphpad.com quickcalc-s. And we quickly go back to this one here. Here we go to this graphpad.com quickcalcs, and here is the, if you want to scan it in, here's the QR code for that. So, first of all, we are presented with this menu here. So we have categorical data, and we have categories. We have cats, dogs, males, females. So that's certainly what we want. So we click continue, and we come to another menu, and here it says analyze a 2x2 contingency table. So let's click on that and see what happens. So we have group 1. This is our male group. So male. Here, group 2, we have female. Outcome 1, this would be cats. And outcome 2, that would be dogs. And we said out of these males, 13 prefer cats and 5 of them like dogs. Whereas with the females, we had 20 cat lovers and we had 62 dog lovers. And we usually would go for something that's called a Fisher's exact t-test, which is always recommended because it does calculate exact numbers. So we click on this and we use a two-tailed test where we say there is no difference between the preference, the gender preference that is in our null hypothesis, but also in the alternative hypothesis, we say there is a difference, but we don't say who likes dogs more. So the next step is to calculate these data. So here it gives us our total. We had 18 males, 82 females, so we have 100 people in total. And here is the value that we get. So I just highlight this and copy it. And now let me quickly paste this in here. There's a T missing, but that shouldn't bother us too much. So we have this. Okay, so we are back on track. Now we got that the two-tailed p-value, in this case, equals 0.0002. And the message that we get is that the association between the rows and the columns is considered to be extremely statistically significant. So what does that mean? It means that our p value, which is 0.0002, is much smaller than our critical significance level. Critical significance level, that was our alpha, which we set to 0.05. That was this 5% that we defined at the very beginning. And we know that if p is low, so if p is lower, p is smaller than alpha, then h naught must go. Or in other words, h naught was our assumption. Here, there is no difference between men and women when it comes to pets. But we can't say that. We have to reject h naught. So we have to reject h naught, and we have to accept our alternative hypothesis, where it says there is a difference between men and women when it comes to pets. So with these data here, with this calculation that we've done with this online calculator, we can see that our null hypothesis had to be rejected, and we have to accept the alternative hypothesis that there is a very clear difference. So hopefully this makes sense, and thank you very much for watching this video clip.